Lesson 3, Probability involving permutations and combinations. So we're going to go back a little bit to our Unit 1 and use the permutations and combinations in solving probability questions. We're going to go straight to some examples. Example 1. 2 cards are selected without replacement from a deck of 52 playing cards. Determine the probability that both cards are kings using combinations. So the probability of 2 kings would be the number of ways of drawing 2 kings over the total number of ways of drawing 2 cards. So to draw the 2 kings, we've got 4 kings in the deck, we need 2, so it would be 4 choose 2. We have a total of 52 cards, so our total number of ways would be 52 choose 2. This gives us 6 over 1,326, which we could also write as a decimal, 0.0045, or as a percent, 0.45%. Example 2. In a card game, you are dealt 5 cards from a pack of 52 shuffled cards. When you look at your 5 cards, what is the probability, expressed in combination notation, that you have 4 aces? So that means we would need 4 aces and 1 other card. So we would use 4 choose 4, that's the 4 aces, and then we have to choose our 5th card, which would be 48, the remaining cards, choose 1, all over our total number, 52 choose 5. We would end up with 48 over 2,598,960, which would work out to be 0.00001847, or 0.001847%. It doesn't matter which way you give me those answers. I slightly prefer the fraction, but either other way is fine. Continuing with our example of choosing 5 cards from a standard deck of cards. For part B, we want 4 tens and an ace. So the probability, 4 tens, 1 ace, would be choosing our tens first. We've got 4 to choose from. We want 4 of them, so that's 4 choose 4. We were looking for our ace, 4 to choose from. We want 1, so that's 4 choose 1, all over our 52 choose 5. This will give us 4 over 2,598,960, or as a decimal, 0.00000154, or 0.000154%. If we're looking for a 10, jack, queen, king, and ace, our probability would be 4 choose 1, that's for our 10. For our jack, it would be 4 choose 1. For our queen, it would be 4 choose 1. For our king, it would be 4 choose 1. And for our ace, it would be 4 choose 1. All over our 52 choose 5. This would give us 1,024 over 2,598,960. We could reduce it so that it's in reduced form. 64 over 162,435, or in decimal, 0.000394, or 0.0394%. For the last part, D, we want at least 1 jack. So we could think of this as being all the possibilities except for no jacks. That would always give us at least 1 jack. So we're looking at the complement here. So it would be 1 minus the probability of no jacks. Now there would be 48 cards in the deck that are not jacks. So we would have 1 minus 48 choose 5, all over 52 choose 5. I've just made the 1 into a fraction with the common denominator, so just to make the subtraction a little bit easier, you might just go right ahead and put this all into your calculator. And we're going to end up with a fraction of 18,472 over 54,145. This would reduce to the decimal 0.341, or 34.1%. Example 3. The word counted has been spelled out using Scrabble tiles. 2 tiles are randomly chosen one at a time and placed in the order in which they were chosen. Determine the probability that the tiles are CO. You notice here now order matters, so we're going to be using permutations instead of combinations. So the probability of coming up with CO, well, there's only one desired outcome, which would be the CO, so it's going to be 1 over. Our new sample space is going to be all the 2-letter permutations that we can get from the word counted. So that's going to be 7 permute 2. Do the calculations, it's 1 over 42. As a decimal, 0.0238, or 2.38%. If you notice, I really do not care which one of those forms that you give me the answer in, so on an assignment or a test, use whatever you feel most comfortable with, unless we specifically ask for a certain form. So for part B, we now want the probability of both vowels. So we're now going to look for all the 2-letter permutations of just the vowels. There's 3 vowels in counted, so it would be 3 permute 2 over our sample space of 7 permute 2. This would give us 6 over 42. We may or may not reduce it, doesn't matter, but it will reduce to 1 over 7, or in decimal, 0.143, or 14.3%. Example 4. Mike's MP3 player contains 50 songs. If he listens to 10 songs on random, determine the probability as a percentage to the nearest 100th. Okay, here I'm specifically asking for a certain form. That the playlist contains Mike's 2 favorite songs. So the probability of his 2 favorite, let's choose his 2 favorite first. So there's 2 of them, he wants both of them, so that's 2 choose 2. He's got 2 songs are his favorite, so we've got 48 songs left over, and we need 8 more on his 10 random list. So that would be 48 choose 8. All over, the total number of combinations, 50 songs, he wants 10 on his list, so that's 50 choose 10. And I'm just putting that right into my calculator, and I'm going to get the answer of 3.67%. Example 5. City Council consists of 9 men and 6 women. 3 representatives are chosen at random to form an environmental subcommittee. For A, what is the probability that 1 man and 2 women are chosen? So, for the probability of 1 man and 2 women, we need to choose 1 man from the 9, so that's 9 choose 1. 2 women from the 6, 6 choose 2, all over 15 total choose 3. This gives us 9 times 15 over 455, or 135 over 455. This can be reduced to 27 over 91, or 0.297, or 29.7%. Part B. What is the probability that Jim and 2 women are chosen? So Jim's going to be on there no matter what. So that would just be 1. That's the 1 choose 1. We're going to still need to choose the 2 women. 6 choose 2. All over our total number of committees, 15 choose 3. And that would equal 15 over 455. We could reduce it to 3 over 91, or 0.0330, or 3.3%. Example 6. A hacker is attempting to break into a friend's security-protected file. The friend tells the hacker all the numbers that are in the 4-digit PIN, but not the order or how many times each digit may be repeated in the PIN. Determine the probability that the hacker correctly guesses the 4-digit PIN on the first attempt if the friend tells her that the PIN contains certain information. For all of these parts, there's only going to be one possible successful event, which is the correct PIN. It's going to be finding the sample space that's going to be tricky. So for part A, we know that the numbers are 4, 5, 6, and 7. So the sample space would be the number of orders that you could put those 4 numbers in. So it would be 4 permute 4, or we could think of it as 4 factorial, and this would be 24. So the probability of finding the PIN on the first shot would be 1 over 24, which would be 0.0417, or 4.17%. Part B. We're given that the numbers are 4, 5, and 6. So we know that one of these numbers has to be repeated to get the 4-digit PIN. So finding our sample space, we're first going to choose which one is going to be repeated. So that would be 4 choose 1. Now we're going to be arranging the 4 digits where 2 are the same. So that would be 4 factorial over 2 factorial. This gives us 4 times 12, which is 48. So now the probability of finding the PIN would be 1 over 48, or 0.0208, or 2.08%. For part C, we are given that the numbers are 4 and 5. Now, we could have 3 4s and 1 5. We could have 2 4s and 2 5s. Or we could have 1 4 and 3 5s. We don't know. So we're going to make it into 3 cases. So the first case would be if we had 1 4 and 3 5s. So that would be 4 factorial over 1 factorial, 3 factorial, plus the case of having 2 of each. So that would be 4 factorial over 2 factorial times 2 factorial, plus our third case of having 3 4s and 1 5. 4 factorial over 3 factorial times 1 factorial. This works out to be 4 plus 6 plus 4, or 14. So the probability of finding our PIN is 1 over 14, or 0.0714, or 7.14%. Part D. If we're given that the only number is 4, well, here there's only one possibility. That would be the PIN of 4444. So the probability of finding the PIN would be 1, or 100%.